Hello and welcome to this clip going through a 6-mark question on infrared spectroscopy and mass spectroscopy. So we'll look at basic infrared and mass spec from the first year level chemistry, and you'll ideally need your data sheet with you to get full use from this clip. So like any spectroscopy question, it gives you a selection of information and it asks you to identify the compound. So the first thing to do is to make sure you understand what it is that they want you to do. There are 3 specific commands that you're being given here. Use all the information, explain your reasoning or your use of this information, and name the compound. So if you've got a formula or a structure you're working from, don't just put the formula and the structure down. You need to convert that back into an actual name. So you need to see this, deduce the structure, and then work out what this compound is. So the first thing to do with any level question is to do a plan. So looking at the information, it tells you that the substance only contains carbon, hydrogen, and oxygen. So your plan means you must include a mass spec analysis somewhere in your answer. So it's got the peak with the greatest abundance is at 43, so that means there's going to be a fragment at 43. What possible fragment might have that MZ value? So looking at the infrared spec analysis, you need to have your data sheet handy for this part. So we've got an OH peak for carboxylic acid, and we've also got a C double bond O. So that would strongly suggest we have a carboxylic acid. So in other words, what I've just been thinking about is matching the peaks on the spectrum to the absorptions and also to the bonds. So I've also now found that I have a C single bond O peak, so I'm using my data sheet to identify it. So now I'm going to lay out my answer. Now I've done a little bit of thinking about it. So we've been 2 minutes into the clip, and that could be 2 minutes out of the 8 or so minutes you might use to actually create an answer for this type of question. So now we've got 6 minutes left. Let's put in the information we've talked about. Now it doesn't really matter which of these sections you actually fill in first. You don't have to necessarily start with mass spec. You could start with things that you're more comfortable with. So you'll notice I've added other information. So if you look at what it says, the liquid turns the universal indicator orange. Now from your own knowledge you should realise that that means that you've got an acid. So compound X must be an acid of some kind. So you know this because obviously the infrared spectrum has told you that there's an OH carboxylic acid peak, so those 2 pieces of information support each other. So the next thing to do is to lay out your reasoning for your infrared spec analysis. You can either write that out separately or you can put it on the actual spectrum itself. Whichever way you decide to do it, you need to make it clear to the person marking your paper that you have made the connection between the data sheet and where the peaks are located on the spectrum that they've given you. So now what we have to do is work out what the mass spec actually tells us. So what I'd recommend doing is laying out the MZ values you've been given. So you've been given 15, 17, 60 and 43. Now we know already that we've got this particular structure because the infrared spectrum tells us this. Now the MZ of that particular section of any molecule would have 45 if that was a fragment. So we know that that's not one of the fragments that we're dealing with here because we haven't been given MZ 45. So clearly there's another part of the molecule that we're trying to guess is present. So I'm going to start by putting a methyl group onto my COOH. So now what you've got is a possible structure from which you could get some of these fragments. So what's the biggest fragment? The biggest fragment is 60 that you're given. Now 60 actually would be that particular structure but as a positive ion. So this might be our molecule. But I'm not sort of jumping for joy just yet because I want to make sure that I've justified in my answer what the 15, the 17 and the 43 are. So if I take that part of the molecule, the CH3 group, and break that off, that gives me a CH3+, which adds up to 15. So if you think about oxygen, it has a mass of 16 and hydrogen has a mass of 1. Those two together make 17. So let's have a look at the remaining section that we haven't tried to break off yet. If OH breaks off to make OH+, then what's left behind? CH3, C double bond O. So now we've justified every single one of those mass spec peaks. So what we now have to do is turn this into an identity. Now we've justified using every single mass spec peak, every single IR peak, and the fact that the universal indicator suggests that this compound is an acid to prove that that structure that I've just drawn there is our compound. Now we've deduced the structure, like I've put down at the bottom left hand corner of the screen. We now have to name that compound. So clearly we've now got ethanoic acid. So what I've done is I've taken every single piece of information and sort of systematically worked through it and put down on my answer what each piece of information has told me. So what I'm doing is explaining my use of it. I'm explaining all my reasoning like the question asked me to do. Okay, so hopefully this was a useful roundup of how to do this type of question on spectroscopy. So until next time, thanks for listening and see you soon.